to the celebrated National Science Day 2024 Indigenous Technologies for Viksit Bharat today. Now, I would like to invite Dr. Punwar, our counselor in charge of science and technology, for his welcome remarks.
Very good evening to all, and thank you very much for applause. It gives me immense pleasure to welcome you all to this National Science Day function. It's my proud privilege. His Excellency Ambassador is involved with the student. He's taking a lot of interest with the student projects. Very interesting exhibition. So I'm welcoming you, and as we are a little late, I welcome all my friends from Indian scientific community and from JST, JSPS, GEMSTEC, uh, and Kyoto University, Toyo University, Tokyo University, Kyoto University. So we can name leading institutions, and people are here today. I am really proud of you. Oh, and thank you for making it to this particular program on National Science Day. As we are a little running late, I'll just conclude it a little short and we will start the program. Thank you.
Thank you very much, sir. To start off, we would like to show you a video about India's Chandrayaan 3 landed on the moon on August 23rd last year. Please enjoy.
This point are providing confirmation of the safety of the landing site.
As expected, the retargeting is going on, and this is a very good signature for the lander. अभी आप ये देख सकते हैं कि लैंडर की ऊंचाई लगभग 65 मीटर के आसपास बची हुई है.
Currently, only 2 engines are now being fired, and we are nearly at zero velocity, vertical and horizontal. We were hovering, and now we are approaching the moon's surface.
धीरे धीरे लैंडर की वेगमान को कम किया जा रहा है और हम अब लगभग 50 मीटर से भी कम आ चुके हैं.
We can see the Honorable Prime Minister, Shri Narendra Modi ji, who is here to encourage us, and he is critically looking at the visuals.
जी हाँ, आप अपने स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल.
People are applauding. Let us all wait to hear from the Secretary Department of Space and Chairman ISRO, Shri S. Somnath.
लैंडर मॉड्यूल पूरी तरह से सेफली और सॉफ्टली चंद्रमा के सतह पे लैंड हो चुका है. ये हम लोगों के लिए बहुत ही गर्व की बात है. हिंदी में एक कहावत है.
Ladies and gentlemen, we're going to be receiving, welcoming His Excellency Mr. C.B. George, Ambassador of India to Japan, shortly. So please wait for a while. Ladies and gentlemen, to begin our seminar, I would like to invite His Excellency Mr. C.B. George, Ambassador of India to Japan. Once again, to begin our seminar, I would like to invite His Excellency Mr. C.B. George, Ambassador of India to Japan, for his welcome remarks.
Good evening, everybody. Senior officials and scientists from JST, JSPS, JAMSTEC, RIKEN, Toyo University, Tokyo University, Kyoto University, Shibaura Institute, Kyoto University of Advanced Science Industries, startups. I'm very pleased to see the young budding scientists from the schools who have displayed their exhibits, which I visited now. So first of all, welcome to each one of you to Embassy of India. My greetings to all scientists and students of science on the occasion of the National Science Day 2024. National Science Day, as you all are aware, is celebrated on 28th of February each year to commemorate the discovery of Raman effect by our great scientist Sir C.V. Raman on 28 February 1928. I celebrated today by visiting RIKEN. I visited there in the morning, had a meeting with the president, went around and saw their laboratory. Very happy to see that. And of course, I also met the Indian research scholars who are working there. So someone told me they spent a lot of time with energy. What I was reminded of, what C.V. Raman ji had done as a scientist during his initial years when he was working as a scientist. Two major events or developments in India comes to my mind when I think about Science Day. One, of course, the very proud moment we had last year when we had launched Chandrayaan-3 to the moon. It landed first time a vehicle has landed on the southern pole of the moon. A great moment. And particularly, it is a proud moment because the topic of the Science Day today is the indigenous technologies. And I'm very happy to reiterate that the entire technology which was used for Chandrayaan-3 was indigenous technology. Every material which was used for Chandrayaan was an indigenous product. So it was a great thing to recall and be proud of. And it didn't stop there. We are continuing that exploration which is going on. Now, the second one of the biggest challenges we faced in our generation was COVID-19 pandemic.
It actually, if you look at it, it denied our children their childhood for 2 years. So much of a disruption. But when we look back, we are not unhappy. For India, as the pharmacy of the world, what we have done is something which makes us proud. Indigenous vaccine, made in India vaccine, was made, and we were able to vaccinate 1.4 billion people, not once, twice. Again, the platform which was used for that vaccine, the vaccination purpose, was CoWIN, again, a indigenously developed digital platform. So when Indians traveled abroad, we didn't use the paper certificate, we used the digital certificate. Not only that, as the pharmacy of the world, as the digital capital of the world, we were able to extend that to many other countries. India supplied vaccines to more than 100 countries. I was ambassador in Kuwait. I have seen the made in India vaccine coming to Kuwait. Okay, so this is what, again, an indigenous vaccine. So it makes a lot of sense when we saying this indigenous technologies for Viksit Bharat. Dear friends, this year we are observing the 10th anniversary of India-Japan Special Strategic and Global Partnership, which our Prime Minister Mr. Modi and the then Prime Minister Mr. Abe signed in 2014. What we have seen in the last 10 years is a complete transformation in India-Japan relationship. Today, I went to RICAN. There are 7 different mechanisms of engagement which RICAN has with India. This is the case with many of the major Japanese institutes and organizations. Science and technology is an important element of our bilateral relationship. In India's transformational journey, Japan is playing an important role, not only as an economic partner, not only sharing just the values of political values, that which we share, of course, which is very important, but it is also science and technology. It is also student exchanges. It is also youth exchanges. This is very important. And that is why this day is important and we decided to celebrate it. I was very happy to go down and see the various projects which are in place. I congratulate the students. I congratulate the teachers. I congratulate the school management for keeping this spirit of science and technology alive and flourishing it. Whenever I travel anywhere in Japan, one important point our Japanese friends ask me is that why is there are so many engineers in India? Why are there so many technocrats in India? So many people focusing on science and technology in India, which is true. We are proud of that. India is in the right path when it comes to science and technology and economic transformation. This is an important step, and I'm very happy to see each one of you who have come here and joined us to celebrate this day. Once again, I congratulate the students. I thank each one of you for joining us today and wish you again a great National Science Day. Thank you.
Thank you very much, Excellency.
Hi everyone. I have a question for all of you. How many of you like exams? Another question. How many of you like quizzes? Okay, more enthusiasm. Then shall we do a pop quiz session now? Okay. The first question is, why do we celebrate National Science Day? Your options are A, to commemorate the birth of Sir C.V. Raman, B, to commemorate the discovery of Raman effect, C, receiving of Bharat Ratna, D, none of the above. Option B, discovery of Raman effect. That's the correct answer. I have a small gift for you now. Okay, next question. Can we have an answer from the second floor this time? Okay, I haven't asked the question yet. So unfortunately, our other mic isn't working, so you'll have to be loud from over there for your voice to reach me, okay? The second question is, when was the National Science Day first celebrated? A, 1980, B, 1982, C, 1987, D, 1990. No, that's the wrong answer. That wasn't that option, unfortunately. That's the right answer. Okay, let's go for another question now. When was Sir C.V. Raman conferred the Bharat Ratna? A, 1945, B, 1954, C, 1955, D, 1964. Let's have an answer from the first floor this time.
B, in 1954.
That's the right answer.
Okay, ladies and gentlemen, as our next program, we have invited a guest speaker to give an online presentation from India. May I request Professor B.S. Murthy, Director of IIT Hyderabad, to give us a talk.
Good afternoon, friends. Konnichiwa. This is Professor B.S. Murthy, Director of IIT Hyderabad, speaking to you on the special occasion of Science Day. All of you are aware of the importance of the Science Day, particularly an Indian invention, which has really made a big news in the whole world and has led to strong collaborations between various countries. So today is a day we should start thinking of how we can grow together through collaborations. I am a strong believer that collaborations will lead to a mutual growth, and a 1 + 1 can be significantly greater than 2 when two people start collaborating and bring synergy through such collaboration. And we see a strong example at IIT Hyderabad, where we have started collaborating with Japan almost close to about 10 years back. And that has led to significant growth in both IIT Hyderabad and the universities with which we have been collaborating for the last and IIT Hyderabad, and that friendship program phase 1 is already completed, and in the phase 1 a large number of close to about 150 faculty members from various universities of Japan have visited IIT Hyderabad, and a similar numbers have gone from IIT Hyderabad to various universities in Japan, and a number of students exchanges have happened. This has led to a large number of publications and a large number of patents, which has now led to an appreciation from the Japanese government, which has helped us to start the phase 2 of the friendship program, which has just started last year. And already about 16 to 18 projects and have been chosen as a part of the phase 2. And in these 18 projects, we will have PhD students jointly being supervised by a professor at Japan, any one of the universities, and one professor from IIT Hyderabad. So this, we strongly believe that such a joint supervision will lead to collaborative research coming out in a big way, in a very formal way, and leading to a large number of joint publications, joint patents. It's important for both these countries to ensure the technological developments happen through such collaborations. We are also now seriously working towards even joint inventions where students of in IIT Hyderabad, for example, joining hands with students from Japan, coming up with some innovative projects, and we will have funding available to support such a thing. Recently, India has started going in a big way to form strong collaborations with the overseas various countries. A committee called an Empowered Committee for Industry and International Collaborations called ECIAC has been formed. Luckily, IIT Hyderabad is leading this particular committee. I am the chairman of that particular committee, where we are looking forward in various fields that are of mutual importance to Japan and India to strong collaborate and grow together. And not only with universities, but also with a lot of industries. I'm very happy to say that a number of Japanese universities regularly visit IIT Hyderabad. We have actually a Japan Day that we have been celebrating for the last about 6 years or so, where almost 20 different Japanese companies come and interact with our faculty and students. And a number of projects are already underway. And in fact, Japanese industries visit IIT Hyderabad and recruit students from IIT Hyderabad. Very recently, I have visited Suzuki Motor Corporation in near Tokyo, where I have been able to meet 25 of our students who are working in Suzuki Motor Corporation. Suzuki Motor Corporation has set up a center at IIT Hyderabad, which is called Suzuki Innovation Center, which they say outside Japan, the first such R&D center that they have outside Japan, which is located at IIT Hyderabad. A lot of collaboration is happening in this as a part of this, and which is leading to a good amount of research in what is called V2X technologies, where vehicle talking to another vehicle to reduce the accidents that can happen during vehicular traffic. So this way, a number of such universities and industries are trying to collaborate with IIT Hyderabad, and this I'm sure will get extended to a number of other universities too. Very recently, I have come to know that JICA has signed an MOU with Telangana government, where a state where IIT Hyderabad is located, for innovation. IIT Hyderabad spends a lot of energy to create a very good innovative ecosystem at IIT Hyderabad, which has been leading to a large number of startups in the last few years. For example, in the last 5 years alone, IIT Hyderabad has more than about 150 startups, which have created more than $150 million of revenue and created more than 1,000 jobs. All this is happening through a lot of innovations coming from our students at IIT Hyderabad. All this, I'm very confident that we can scale it up and ensure that such kind of innovations can happen jointly between Japan and India. And we would like to see that such joint collaborations leading to joint inventions, which will help both the countries grow together. I'm very confident that today on this Science Day, we will remember the great scientific contributions that have come from both the countries and see that how such contribution can be strengthened further through joint collaboration. I'm very happy to be among all of you on this special day and be a part of the celebrations on the of Science Day. And I'm sure that we will move forward to working together to ensure both countries grow jointly in science and technology to greater heights. Thank you very much for this opportunity. I'm grateful to the Embassy of Japan for giving this opportunity, and also JICA for strongly supporting us, and the whole Japanese academic and industrial ecosystem which has been collaborating with us for mutual growth. Thank you very much, friends.
Thank you very much, Professor Murthy.
So we heard a very interesting speech from Professor Murthy. Shall we have another round of quiz now? Okay. Who's that? Who said no? Okay. Please tell me how you write exams. Okay, next question is, which university did Sir C.V. Raman get his bachelor's degree from? A. Government College University. B. University of Punjab. C. Indian Institute of Technology. D. University of Madras.
That's the University of Madras.
That's the right answer. Okay, let's go upstairs now. Where was Sir C.V. Raman born? A. Tiruchirappalli. B. Madras. C. Goa. D. Thiruvananthapuram. Which one? Try a little bit more. Someone's very offended here. That's the right answer. Guys, let's keep this tempo going, okay? The discovery in which field of physics earned Sir C.V. Raman the Nobel Prize? A. Vibration of sound. 2. Scattering of light. 3. Both. D. None of the above. 2. Scattering of light. That's the right answer. Okay, one last question, okay? Second floor again. What is the name of the student who helped Sir C.V. Raman in his research, including Raman effect? A. K.S. Krishnan. B. K.R. Ramanathan. C. G.N. Ramachandran. D. Shivaramakrishnan Pancharatnam. I see a hand there. Unfortunately, option B isn't the answer. Option A is the right answer.
Okay, ladies and gentlemen and students, next we would like to show you another video. This documentary is on Bharat Ratna Sir C.V. Raman.
वर्तमान साइंस साथियों, दुनिया में ऐसा कोई देश नहीं है जिसने साइंस
The Earth is also called the blue planet. But why does it appear blue? This question has been a matter of debate for a long time. Philosophers have been discussing this, and the argument could also be found in many ancient stories. From the ancient India, where the sunlight is depicted as 7 different rays, to ancient Egyptian civilization, where the people worshipped the sky goddess Nut. Greek philosopher Aristotle was the first to ask why the sky was blue. He speculated that the color is the result of an interaction between the air and deep space. This perspective became the basis for the future thinkers, like the celebrated Renaissance artist Leonardo da Vinci. Da Vinci's experiments gave him a perspective towards the scattering of air molecules for the abundance of the blue color. As time progressed, Sir Isaac Newton began a series of experiments, and he rightly concluded that the clear white light is composed of 7 colors. Light was then compared to waves, and different colors of light have different wavelengths. Lord Rayleigh correctly theorized how light scatters when the sunlight enters the Earth's atmosphere. The atmosphere then diffuses the sunlight. He also theorized that the blue color of the sea was also because of the reflection of the sunlight. But one scientist from India was not accepting of this theory. Educated entirely in India, C.V. Raman's work on acoustic and percussions was well known to the Western world. His article, Newton's Ring in Polarized Light, was published in the Nature's magazine in 1907, the first for IACS. He was invited to give a lecture at Oxford in 1921. Such was his reputation that his hosts were J.J. Thomson and Lord Rutherford. On his return journey aboard the SS Narakunda in September 1921, he observed the blue color of the Mediterranean Sea. Rayleigh was right about the blue color of the sky. Rayleigh's hypothesis of the sea reflecting the light and hence the sky appearing to be blue was generally accepted as correct. On this journey itself, he started writing an article, The Color of the Sea, to send it to the Nature magazine later. Raman observed the sea without the influence of sunlight using a Nicol prism, and he found out that the sea was more blue than he expected. After discovering the nature of light scattering, Raman focused on the principle behind this phenomenon. The scattering experiments explained, no matter what scattering medium is used, the medium will always produce polarized light within its color spectrum. K.S. Krishnan, a new research associate, was conducting the experiments with C.V. Raman. They concluded their modified scattering spectra in February 1928. For this discovery, C.V. Raman was awarded the Nobel Prize in 1930. The Raman effect has revolutionized the world of science, and it has led to several other discoveries and inventions in the future, and it will continue to do so in the coming centuries.
Okay, now let's go with one last session of quiz. What was the theme of National Science Day 2023? A. Science and technology for a sustainable future. B. Women in science. C. Chemistry in integrated life. D. Global science for global well-being.
Option C.
Option C is not the right answer.
Option B.
Nope. Next try, please.
Option D.
Nope. Option A. Option A.
Option B.
Option A.
Option C.
Okay, last try. Last try. A. Nope. Okay, let's go to next question. Come down. Next question. Okay, this question is for the second floor. Which organization proposed National Science Day? A. Council of Scientific and Industrial Research, CSIR. B. National Council for Science and Technology Communication, NCSTC. C. National Academy of Sciences. D. None of the above. Option B is the right answer. One last bonus for the first round, first floor. What is Sir C.V. Raman's full name? This question doesn't have options. I see a hand there. Are you sure?
Chandra Venkat Raman.
That's the right answer. It was nice having the quiz, guys. See you next time. Bye.
Thank you very much for your participation. Now we would like to have a group photo. Could our photographer come on to the stage and take a photo from the stage?
Look at the camera, please. 1, 2, 3.
We would like to have one more photo with everyone standing up. Please, thank you. Please look at the camera, please. And smile. Cheese, one more time. Cheese.
1, 2, 3.
Thank you very much. Okay, ladies and gentlemen and students, as our last program of today's seminar, I would like to request Dr. Swadin Bera from GEMSTEC to give us a talk.
Good afternoon, everybody. Namaste. So, distinguished guests, ladies and gentlemen, boys and girls, my name is Swadin Behra, and I'm going to talk to you about the digital twins technology we are developing for ocean and atmosphere. And I'm going to work on some aspect of it with IIT Kharagpur under a fellowship called Vaibhav Fellowship. Vaibhav Fellowship means the fellowship is given to Indian origin researchers working outside India. We have several fellowships, awards inside India for Indian researchers. We also have fellowships and awards outside India for everybody, international researchers. But this one is a great initiative under the guidance of Prime Minister Mr. Narendra Modi ji and our Science and Technology Minister Dr. Jitendra Singh ji. So they have kind of introduced this new kind of fellowship in which they recognize Indian origin scientists working outside India. In that way, it's a great initiative to recognize Indian scientists of eminence working outside India, and also kind of collaborating with them. You heard Professor Murthy talking about collaborations. So this is also a great initiative to bring that collaborations between premier institutes of India and the outside institute through these fellows who are eminent scientists in their own field. So this year they have selected 22 scientists, and I'm lucky to be one of them. I feel very honored to receive this award while working in Japan and working in JAMSTEC. My executive director is sitting there. So it's a great honor and privilege to work under this Vaibhav Fellowship. So next slide, please. As you know, we are facing the great challenge of global warming. Probably most of you know already what is global warming, the climate change. The earth is warming up because of the greenhouse gases we are producing because of our anthropogenic activities. And you know, in order to mitigate the effect of those extreme events that we are facing because of global warming, we are facing many extreme events. Severe typhoons, cyclones, floods, droughts, heat waves. And in order to kind of understand them and predict them, we need to monitor ocean and atmosphere, as well as we need to predict them in near future and in long-term futures. So to do that, we are kind of developing some kind of models, computer models, to simulate them, the present climate and the future climate, so that we can devise some plans to mitigate the problems we are going to face because of the climate change. Ocean is playing a big role in both climate change and also disasters. You know, when there is a storm like hurricane or cyclone, we get a lot of storm surge, sea level rise, and flooding of the coastal areas, and also different hazards related to that. In order to understand that and also kind of predict them, we are developing what we call the digital twins of the ocean. Actually, the United Nations already recognized the importance of the oceans. So this decade is named as the Decade of Ocean Decade by the United Nations. It started in 2021 and will continue until 2030. We are kind of in the middle of that. And the United Nations Decade of Ocean is kind of recognizing 10 challenges that we must address. Challenge one is mostly related to the ocean pollution, especially the plastic pollution we are producing now. And like that, we have 10 challenges. 10th challenge is how the humanity is interacting with the sea, with the oceans. Ocean doesn't care so much of interacting with us. We need to interact well with the oceans so that the oceans become sustainable and available to all of you. Our generation is going away now. Your generation is going to experience the ocean. So we need a good ocean and a healthy ocean. And for that, we need to kind of monitor, model, and create digital smart interfaces so that children like you can play with those digital twins to know, okay, if you do this thing, what happens? If you kind of produce a lot of carbon dioxide and put them into the ocean, what happens? What happens to the biosystem in the ocean? What happens to the physical system in the ocean? You can change something and see the sensitivity of the oceans by playing with those digital twins. In a sense, it also helps you to learn the processes. And that's one of the component of digital twins, which I'm involved in Challenge 8. Challenge 8 is the digital representation of the oceans, and I'm involved with that. And digital twin of the ocean is one aspect of that. Next slide, please. So as an example, I'll show you what we are doing at JAMSTEC. We are developing this prediction system called the Japan Coastal Ocean Predictability Experiment, JCOP. And the idea is to kind of provide forecasts at 200-meter resolutions. So a 200-meter resolution will provide forecasts all around Japan coast for various things, including disaster management, and also, most importantly, ship routing. Like we know, we are dependent on oceans for various things. For food, we are getting fishes and other food items from the oceans. And transportations. So for transportations, we are kind of producing a lot of carbon dioxide. If we can optimize the ship routes through our digital twin of the oceans, then we can reduce not only the cost of the gasoline they're going to use in the ships, but also will reduce the carbon dioxide. And in that way will help to mitigate global warming. Next slide, please. We are also producing this, what we call the 4-dimensional virtual Earth. So children like you can play with them. It's not only for playing. Of course, it has other purposes, like the stakeholders can use information from that for like farming, agriculture. You need the information when it is going to rain and when it is going to be sunshine. So we can use those interface to see what's going to happen in the future and take actions depending on what is your need, from farming to even like going on a cruise or something. And also, like if you are traveling someplace, you want to know what is going to happen next day or 2 days, but what we are producing here is what is going to happen in next month, next 2 months, next 3 months. So you can plan ahead all your activities. And next slide, please. And the other thing I want to work with the IIT Kharagpur is to kind of improve the predictions of monsoon. Indian monsoon is very important for India. Large part of our GDP, 2 to 5% of our GDP is dependent on Indian monsoon rainfall. A lot of employment is coming from the Indian monsoon farming. And also our food and everything is coming from those farming. So in that sense, Indian monsoon is very important. We are able to predict the monsoon rainfall one season, like 3 months ahead to 6 months ahead, quite well now. but we are still not perfect. We know that the monsoon is dependent on several factors, including what is happening in the Indian Ocean and what is happening in the Pacific Ocean. Many of you might have heard the terms El Nino. Yes. So it's one signal which is affecting the monsoon. The other signal in the Indian Ocean, which we call the Indian Ocean dipole. So those kind of things affecting monsoon, we already know that. We are able to model them, and those are helping us in predicting the monsoon, but it's still not perfect. So in my work with IIT Kharagpur, we are going to kind of use how the vegetation over India is influencing our monsoon. The forests, the crops, how they are affecting the monsoon rainfall, and how we can improve the prediction of monsoon by using those information. That's what I'm going to work with IIT Kharagpur. Okay, that's all. I'll stop there. Thank you very much.
Thank you very much, Dr. Behela. So with this, we would like to conclude our event today. The embassy would like to express gratitude to all of you for joining the seminar today. Thank you very much. We have prepared some tea and refreshments at the lobby area. Please enjoy. And then also in the basement hall, we have exhibit.
There is a talk online from New Delhi on quantum technologies for Viksit Bharat. So we will be live streaming. So if you are interested and some people joining, then we will live stream. So it's up to your interest after the tea and snacks.